Hello. Today I'd like to talk about a very famous puzzle known as the Monty Hall problem. Basically, this problem is about a game show. That in the game show we have 3 doors here, and there's a prize behind one of the doors. So let's say there's a car here behind the first door. And in the game show we have the host and participant. And basically, to start with, the participant or the player will pick one of the door. Let's say he picked the third door here. And then the host of the game show, knowing that like where exactly is the prize or the door, the car, he will basically open one of the remaining door, and the door that doesn't have the prize. So in this case, this will be this door here, right? And then I show into the player that, okay, there's no prize behind this door here. And he'll ask the player if he wants to switch his choice. So basically the question of the Monty Hall problem is, should the player switch his choice or not? And of course, this is really a probability problem. And what we are interested to look at is really the probability for 2 cases. Basically, what's the probability of winning? The player get the white door if he stick with his original choice, and also what's the probability of winning if he switch sides. I mean, switch to the another doors. So there is like probability of sticking of winning, probability of winning if stick to original choice, and also probability of winning if switch door. So this is actually I guess it's actually a rather tricky problem that many people look into that before. Historically, I guess like they have almost half a year or like a year debate on the solution of this problem on the magazine column. If you're interested, you can just read the article on Wikipedia. There's a long article about this problem. But here I just want to explain the solution very quickly. So basically, if we think of the first question here, what's the probability of winning if we stick with the original choice? If you think of the player, if we stick with the original choice, what it means is that basically the player ignores whatever the host is doing, right? You can think of the player is basically doesn't know what the door the host pick at all. So in the sense, you can ignore this information completely. If you think of the first choice, if we ignore this completely, then apparently the player will get the white door with probability simply 1/3, right? With the assumption that he has no knowledge of like which door is more likely to have the car behind it. So the first one is pretty simple. And now if given this one, then we see that if you have this host come into this picture again, then basically there's only 2 doors left. He will win, either he will pick, I mean, there's no other third option here. So, because like the probability of winning, if we stick with the original choice of 1/3, then the probability of winning, if he switch door, should be just 1 minus 1/3, right? So that should be just 2/3. Okay, I know this is a quick argument that it may sound confusing here. So instead, let me give another argument for this second question here. That should be much easier to follow. So let's say like the player is going to switch door like every time. So let us just draw these 3 doors again and draw the price. Maybe the price this time is in the middle. So now let's see, if the player picks the first door in the first time and the first place, and then what the host has to do is it has to open one of the remaining doors doesn't have the car. And since this is the only remaining door doesn't have the car, he has to open this. As the player is always going to switch switch to the another remaining door, then he will open this door. And you can see that for sure in this case, the player will win, basically, will get the car. And by the same argument, if the player start with picking the third door, now the host will open the remaining door will be the first door, and then the player will switch side to the remaining door. That will be this second door. Again, in this case, he will win. Oh, let me just give some caption here. Maybe it's easier to read here. So this is the choice of the original choice of the player, and then this is host open, the door that host open. And then the one in red is the final choice. Now let's look at the third case here. In the third case, let's say the player picks the white one actually at the beginning. Now the host can open either this door or this door here. But in either case, as the player is going to switch side, he'll switch to the one that doesn't have the car behind it, because he has the right choice at the beginning. If he switch, he'll always lose. And therefore, like in this case, he'll screw up. So in this case, you can see that like by simple counting, 2 out of 3 times he'll get the car. So therefore, the probability of winning will be just 2/3, as we explained earlier. And okay, and this is the Monty Hall problem.